So I think we can actually go ahead and get started since we have a lot to cover today. If you want to just go to the next slide. So thank you everyone for being here. We're really excited to do another webinar on MCP. This will run for about 45 minutes. And if you do have questions that come up, please try to submit them down the bottom in the Q&A panel. We have Kevin from the Temporal team who's going to be keeping an eye out and answering questions as we go. So just let us know whatever is on your mind. And we will be sending out a recording to everyone who registered. So you'll just keep an eye out in your inbox for that, as well as some follow-up resources after this session is done. So if you want to go to the next slide. So my name is Megan. I'm your host today, and I'm joined by Cornelia. If you all were on the last MCP webinar, you know that we have a lot of good stuff in store for you. So I'll pass it to Cornelia to do her introduction.
Great. Thank you so much, Megan. And my name is Cornelia. I am here at Temporal as well, and I'm a developer advocate. And I just love Temporal and more and more loving all the technology that's coming out of AI, out of the AI space. And let me tell you, we have some fun in store for you today because this MCP topic is extraordinarily interesting, kind of mind-blowing in a few places. So with that, the other thing, Megan, if you would, Megan's going to be watching the Q&A as well, and I would love for her to interject with if she finds questions that are very, very timely and topical in that moment, she will go ahead and interject and ask those questions. We'll also take some time for questions at the end. But with that, let's jump in. So what I want to do is this is our second MCP webinar, and so I just want to give you a brief recap of what we did with MCP about a month ago. So in a previous episode, if you will, um, we started with this, which was the notion that you shouldn't just be taking your existing open APIs and just projecting them out into as MCP servers, because MCP servers essentially are APIs for AI or APIs that LLMs are going to leverage. And so what we talked about was the fact that you're probably going to be building MCP servers that actually orchestrate a number of lower level APIs into coarser grain things. And what is the technology that is extremely suitable for orchestrating a number of different API calls? Well, that's temporal. And so we talked about this, and we, for the most part, talked about kind of the request response. So the architecture, and there's a QR code at the end, by the way, that will take you to the previous video if you want to go back and take a look at that. So we did some MCP fundamentals, talked about the MCP client server architecture and the way that we made those downstream calls, how we used activities. So there's some foundational things there. We also, and the way that we did that was we used this particular example. So we had an MCP server that had a weather tool, and it made two downstream requests, and we saw how those things were orchestrated and how they were durable. So with that, we did ask you for some feedback, and we got some great feedback from y'all. And you ask for things like, hey, how about humans in the loop? How about when we want to use some more advanced features in MCP, which human in the loop is one of those? There's something called sampling. One of the questions in your poll, by the way, is how much exposure do you have to some of these advanced MCP features like elicitation and sampling? So those are the things that we're going to do, human in the loop, and what happens when an MCP server actually needs an LLM. Then we're going to talk about well, what if we want to leverage those tools in a scenario where there isn't a user interface, kind of a headless AI application. So we have a simple example that we'll do there. And then we'll talk about remote and local MCP. That was something that y'all asked for as well. So before we jump into the meat of it, let me tell you about the scenario. So I've put together a sample application, and you'll get the QR code. For those of you who came last month, it is the same repository, the same GitHub repository that we made available to you then. So there's a new example in there, and that example is this. So, Hacker News is obviously a vibrant community where people are posting all sorts of things. And they've intentionally kept their user interface and basically their APIs at a very minimal level. So, this is your Hacker News UI on the left-hand side, and you can see all the different posts. And you can see that I've searched for something. I've searched for a topic of AI. But if I want to see what's inside of those posts, I have to click on the links. I have to click down into the URL. It pops up in a new window and I have to skim it. So what I've done here is I've written a simple little application that takes the newest Hacker News stories and generates summaries of the content that is linked to from those Hacker News posts. So you can see that on the right-hand side, and I'll show you this all live in production. So basically, this is what the MCP server does. My Hacker News tool gets the recent Hacker News stories, and you can see that it does that via this Algolia query interface. So you can query something. Then for each one of the top hits, and I have it configured to look for 5 top hits at the moment, it renders the URL. So yes, I'm doing a little bit of poor person's version of rendering URLs, screen scraping, if you will. I'm not very good at that, and frankly, I vibe coded most of that. But we're rendering the URLs, and then we're taking that URL, the text from that rendered URL, and we're sending it back over into the LLM for summarization. And then we're generating the report like you saw. So that's the scenario, and that's all of the demos. We're going to do lots of demos as we go through. So now the first thing on the agenda is, what are we going to do when the MCP server needs something from the user? So notice that I had MCP server underlined. So we we have a scenario here, and I'll show you the demo in just a second, where we want some human interaction in our application. So the first question is, where is that human in the loop interaction? Is it in the application? So what you can see here, and there's a link to a blog post where we talk about these different styles of AI applications. You might have a simple AI application that has a linear flow, and you can see in there that there's some potential steps of user interaction. I've invoked an LLM, I invoked a tool, so I made an action, then I asked the user for some input, and all of this was pre-decided. Or if I've got an agentic loop going on, so I'm constantly, continuously looping and the LLM is driving the flow, you can see that I could have some optional user interaction. And that's something that I can decide when I'm building my agent. So I could have user interaction. But in this particular case, remember I underlined the MCP server needs interaction. So what happens when the tool, the action needs human in the loop? Now, wait a minute. What on earth does that mean? So I've been doing this for a long time. I spent the last 15 years really, I was very lucky. I was early on in the whole microservices movement, even wrote a book about it because I spent so much time on these microservice architectures. And I am very familiar with this model where what we're doing is we have our application, it makes all the decisions on when you're going to do user input and those types of things. And then when it makes the API call, it makes an API call. And APIs are either request response or they're event driven. But this notion that the API itself wants some human interaction is kind of mind blowing for me. Now, for me, the jury's still out. This is what MCP allows you to do here. It's part of the specification. Whether that makes sense that we have interactivity in APIs or not, I don't know. I think that industry will see how that goes. But that said, given that it's part of the MCP protocol, that gives us the opportunity to experiment with this idea of interactive APIs. And so that's what I've got working for you today, and I'm going to show you how that works. So with that, let's go to the first demo. So I'm going to come out of here, and just like we did in the last webinar, the actual flow that I showed you, the tool, the MCP's tool, server tool, is implemented as a temporal workflow. So I'm going to come over here and you can see, I'll just go ahead and refresh this, that I have my temporal server working and I don't have any workflows running yet. So let me come over here and I'll show you more of the architecture in just a moment. But I'm going to start a few things. Oh, I didn't clear my windows, but I'll just go ahead. I'm going to start my temporal worker. For those of you who are new to temporal, don't worry about these details around starting temporal workers. We have lots of materials out there that can help you understand the architecture of temporal. We're not going to cover that in detail today. But this is really where my workflows are running, is within these worker environments. And now I'm going to start my client. So when I say client, what I mean here is I'm going to start my application. So this is my AI application. My AI application in this particular case is super simple. It asks for a user prompt, sends it to the LLM, maybe does some other things. You'll see that in just a moment. And then it responds to the user. So I'm just going to say, hey, hi, how's it going? And so you'll notice, and I'll go into it in more detail, but it actually loaded up a number of tools, and I'll show you the code in just a second. It loaded up a number of tools that were available to the client. And then down here, it basically just sent it to the LLM, and the LLM said, you just said hi. I don't think you want to invoke any tools. And it just responded. Okay, and I'm going to control C out of this. I'll show you the code in just a minute. You'll see why I control C out of that in just a moment. And so basically that's my application. It prompts the user and then it decides, it invokes the LLM and maybe does some tool invocation after the fact. In this particular case, it didn't do any tool invocation. So let's run it again. And this time I'm going to say, what's my hacker news? And we'll see what happens. Ah, here, check it out. So what it did when it went to the LLM, and before it went to the LLM, again, notice that it loaded up these tools. I've configured those tools into my client. And just like you would with Claude for desktop, and that's what we did last month, is we configured these tools into our client environment. So I've configured the tools into the client environment. It loaded those up. It established connections to those tools and then made all of that information available to the LLM. So now the LLM said, oh, you're asking about hacker news stories? I have a tool that does things with hacker news stories. And it recognized that based on the natural language description of the tool. We covered all of that last month. Now, the first thing you notice here is that I have invoked the tool. This is really important because this goes back to that point I was making about like interactive APIs. Whoa, wait a minute, what's going on there? So this interactivity is coming from the MCP server. The MCP server says, oh, I see that you haven't told me what topic you want from Hacker News. So the next line you see here says handling elicitation for Hacker News. So that means that the MCP server is going back to the client and saying, hey, I need more information. And it does so. I'll show you the code in just a moment. And now the user has the opportunity to interact and provide that topic. I'm not going to do that yet because I want to show you the code and I want to get there incrementally. So let's see. The first thing that I want to do is I want to show you over here is that, and I'll show you the architecture of this in just a moment. But what we have here in the MCP tool is you can see that we're setting up some stuff. We're actually, for those of you who are temporal users, you'll see in a moment that I've created a long running workflow here. So I'm using an entity workflow. But if we come further down here, you can see that one of the first things that I'm doing, even before I get into this loop, which I'll show you in just a moment, is that I'm handling a query. So I'm waiting, in fact. So it's checking with, it's started that workflow. And in fact, let me show you that. So if I refresh here, you can see that I've started this hacker news story and it's waiting. And what's it waiting on? Well, it's waiting on this right here. It's at this line of code where it's saying, hey, I'm not going to go any further in my MCP server implementation until I get back a what? A topic. And so the way that that topic is getting set is through a temporal query. So or actually, it's getting set via this execute update. So the execute update is what's setting the topic. And so it's waiting for that topic to be set. So you can see here that until I have a topic, I'm just going to be in this wait state. Okay. So now let me go back to my slides. I want to make sure that I'm showing you the things that I want to show you in the right places. Okay, so remember that's where we were. And so let's talk a little bit more. Let me show you what's happening in that elicitation. So this is the screenshot that we had before. This is what my tool is doing. But in fact, it's doing a little bit more because what we want to do before we invoke that first activity, that Hacker News API, is we need to understand what topic you're interested in. And so that's that code that I just showed you. That's where we put the elicitation before the call down to the Hacker News API. So the way the elicitation works is it sends a request back to the client, and then it sends the topic in here. Okay? So I am going to show you, I'm going to go ahead and invoke that, provide that elicitation response. I'm not going to go through all the details in the slides here because I'm showing you the code live. But a moment ago, I just showed you this wait condition. The other part of it is the rest of the elicitation. So let me show you that actually live in the code. So I showed you the server, and what we want to do now is we want to look for, sorry, I've lost so I'm just going to do a search on elicitation. Okay, here we go. So this is on the server side, what you can see here, that it is invoking right here in line 32 is where it's contacting the client. And it does so because the context has been passed from the client into the MCP server. Remember, it's a client server architecture. And so it makes this elicit call on that context object. And it says, what topic are you interested in? That is exactly the message that is being displayed here. The client is displaying this, not the server. The client is displaying this. And then it's waiting for that response. Now, if we go over to the client, let me show you something else here. So this is my client application. It is both my application and it's the MCP client all in one. The MCP client is implemented here. I've used Fast MCP. Part of the reason I used Fast MCP is it has great support for all of these advanced features. Not all of the clients out there, and by the way, there's a poll questions later on what are your favorite clients that you're using for MCP? Is it Claude for desktop? Is it Claude Code? Is it Goose? Are you building your own? What I've done here is I've built my own because a lot of those clients don't have full support for things like elicitation and sampling. So I've built my own here, and that's what's defined in this class. And I've used Fast MCP. So what you can see here is you can see a bunch of methods. So you can see methods that do things like list tools. So remember earlier when I showed you in the command line that it had loaded up, it had established connections to those tools. Well, that's part of the MCP protocol. What it did was it said, well, let me look at the servers that I'm connected to. Let me communicate with those servers, get a list of tools, and then I'll make those tools available to the LLM as it gets called. So you can see here that there's a number of different methods. So you can call tools, you can connect and disconnect. But down here, we see, and I'll get back to the sampling in just a moment. You can see here's the code on the client side. So it takes the message and then it basically prints out that message and says, all right, give me some input. So this is happening on the client side. Okay. As soon as that input is provided, then that message goes back to the MCP server and the MCP server continues to execute. So what's super interesting about this protocol is that we call the MCP client and server, but when we're doing elicitation, we are actually flipping the roles. The server is now acting as a client, and that happens over, depending on the protocol. At the moment I'm running this locally, it happens over STD IO. We'll get back to remote and local in just a bit. So the server makes a request to the client processes that request in this particular case, taking input from the user, responds back to the server, and then it continues operating. So with that, let me go ahead and finish that request response. I'm going to say, I'm looking for stories on the topic of AI. So now if we come back to my temporal workflow, you can see that indeed my workflow is now continuing. Notice here, let me blow this up a little bit. There we go. That's better. So you can see here that the next thing that happened is it set the topic. It set the topic after it heard back from the client. And the way that it set the topic was with a workflow update. So this is happening in the workflow. Now it's making the Hacker News request, and you can see that it's rendering the content and updating the summaries. Okay, and we'll come back to how the summary updates are happening in just a moment. So let me pause there. Let me go back to my slides and see if there are any questions, any burning questions that you want to interject with Megan, or are we doing okay?
Yeah, Sophia actually had a question from earlier in the call. So in the beginning of the call, you mentioned that simply exposing an existing OpenAI existing API via MCP isn't ideal, and she was unsure why it's not ideal.
Okay. And we covered that in more detail in the previous video, so I'll invite you to go back there to see a more detailed description. But the short of it is that low-level APIs are harder for LLMs to reason with. So if you want your LLM to figure out, oh, in order to deliver this high level user experience, I need to make a low level API call to figure out what weather region my Latin long are in, because I don't get weather for a Latin long, I get weather for a region. So we did this last time. So I can take my Latin long, make one API call to get the region, make another API call to get the weather for that region. That type of low level um, uh, orchestration, having the LLMs do very low level, basically stitching together that flow is a lot harder. And so having the LLM alone do that is difficult. So that's why Jeremiah Lowen, he's the creator of Fast MCP, which basically does allow you to do what I'm telling you not to do. He himself says, don't do that because LLMs don't speak low-level APIs particularly well. They're much, much better at speaking coarse grain APIs. So that's the TLDR on that. Okay.
Perfect. Thank you. I think we're good.
Okay, good. So I showed you all that code and I showed you a little bit at a high level what that looked like in terms of our flow, but let me start to show you what the architecture looks like for these MCP servers where you've got the workflow implementing the tool itself, but then you've also got this client server protocol that is doing this like elicitation back and forth. And I alluded to it. I showed you pieces in the code, but let me show you the picture because I need pictures to understand architectures. So this is the picture that we showed last month. We've got a client server architecture, right? So what we've got then, if we start to blow that up, is we've got an AI application. In this case, my AI application is just that very simple interface that prompts the user, does something, invokes the LLM, perhaps does some things like calls an MCP tool, and then finishes. Um, So that's my AI application. Within that, we have the MCP client, which I showed you. I showed you the code. We blew that MCP client up, and you saw the list tools, you saw the elicitation handlers, those types of things. So that's what's happening on the client side. On the server side, what we really have is we have broken up our server implementation into two layers. One layer I'm calling here the MCP protocol handler. And that's what was in the hackernews.python file, .py file. That's again where I'm using FastMCP because I didn't want to implement a low-level protocol myself. I used FastMCP to do that. By the way, FastMCP is included in the official reference implementation for MCP and for their official SDK as well. So it's hugely widely used. So that's the protocol that knows how to speak that elicitation protocol. But the temporal workflow is running on its own, and it has its protocol that we use to interface between that MCP protocol handler and the business logic itself. And that's what this looks like. So I've got the elicitation handlers on the client side and on the MCP protocol handler. And then, as I showed you, the interface between the elicitation part on the server side and what's executing in temporal is done via temporal workflow updates and with temporal queries. Okay, so this gives you that architecture. All right, so that takes care of the first part. And we spent a lot of time. You're probably all thinking, wait a minute, she had four things on the agenda. We're half an hour in, and she's really only done the first one. Well, that was set up for a whole bunch of other stuff. So, helping you understand that architecture and the way that we implement these things, the rest of the stuff is going to flow more quickly. So, the second thing is, so that's human in the loop. The second thing is, well, what happens when the MCP server needs an LLM? Now, you could just say, hey, I'm going to just do this picture, which is I'm going to put my own keys into my MCP server, and I'm going to connect to my own models at the back end, my own model provider. But that now puts the financial burden on the MCP server itself. Whereas maybe that server is actually just providing functionality, and it's the application that's responsible for providing the LLM. So that's really the scenario, is, hey, instead of the MCP server being responsible for the token costs and all of that stuff, and most importantly, for securing that LLM, making sure that you can only use LLMs that are approved by your organization, et cetera, et cetera. That is something we want to do here is we want to push that responsibility for the LLM itself and all of the security and compliance, and frankly, the costs around that LLM back to the application, which is a natural place for those responsibilities to lie. So this is the picture that we're doing is we're pushing that the responsibility for that LLM back onto the application. So how does that work? Well, I'll step you through the code in just a moment. And in fact, out of brevity, I will do that here in these slides. So what you can see here is this is on the client side. I'm sorry, on the MCP server side, where I'm implementing, going back a screen, so I'm implementing the render URL and the summarization step. And so that's what you see here is I'm processing a single story. And so you can see there that this is where I'm invoking my activity to do my poor person's version of rendering. I'm not very good at it, but I managed to get it working where I can render some of these URLs, most of them. And then you can see here that I am waiting on a condition. What's the condition I'm waiting on? I'm waiting on the summary to be available. So you can see here that for this particular story, and remember I said that I'm doing 5 stories. For this particular story, I am waiting for the summary to be available. How is that summary becoming available? Well, it's becoming available when a workflow update makes it available inside of the workflow. So here you can see that in the workflow update, I'm sending that summary in. How am I getting that summary? Well, it's exactly the same protocol. Well, it's not over elicitation, but it's the same kind of reverse request response protocol where the MCP server becomes the client and the MCP client becomes the MCP server. It's exactly that same thing here. So on the MCP server side, you can see here that I'm sending that sampling request over. Um, and I'm handling the query when it comes back. So when I get a response from that, I'm sending the message back in. And then on the MCP client side here, I've got an MCP client handler. So let me come back and I'm going to show you that, in fact, in code. So I do want to show you, if we go back to the client, remember we were here in the handle elicitation. Down here we have handle sampling, and it pretty much looks the same. There's a little bit more work that we need to do in terms of parsing the response and all of that stuff. But here's the important part. Notice this is where I'm invoking the LLM. So I'm invoking the LLM client side inside of my application. Okay, so going on with the demo, let me come back over here into Temporal and explain the rest of this. So you'll notice earlier that we went so far as to say, look, after the elicitation, we set the topic. Oh, perfect. You see that it just kicked in again. I'll explain that in just a moment. So I set the topic, then I made that Hacker News request. Then I made in parallel those 5 different requests to render the URLs. And then these update stories that you see here, that's where I was using workflow updates from the MCP protocol handler on the server side. It had received its response from the MCP client. Okay, here are the summarizations. And it had used workflow updates to inject those summaries into the context of my temporal workflow. Now my temporal workflow has those things, and it continues executing. Now, the one thing that I failed to demo, I completely forgot to demo, is I can come over here and I can, in fact, stop the client itself. And I'll come back to this in just a moment. I can stop the client. Actually, I just stopped the server. I used to have my windows switched. But you'll notice that because this is temporal, I just turned off my workflow logic and I turned it back on, and that's all durable. So you'll notice that it just continues to run. But if I turn off, actually my client finished here. I want to show you something here. Let me come back to this. Let's see if this has completed. It has. Um, so if I restart my client all the way from the beginning, and I say, what's my hacker news? You saw that it invoked those again. And now notice that it says it's invoking the tool, get latest stories, but it's not prompting me for the topic. And that's because while the MCP server protocol handler is completely stateless, I just killed it and brought it back. All of that state is being handled by the durable workflow on the temporal side. So the next time I get back to my architecture diagrams, I'll emphasize that. Oh, and by the way, here you can see, in fact, if we scroll up, you can see that those messages invoking the GPT-4o mini, that's this um, print statement right here. That's that log message. So you can see that, in fact, on the client side, it was invoking the MCP model via sampling to generate those summaries. Okay, so yes, we'll come back over here. And Let me scroll up just a little bit. And so you can see here that in fact, if we click in on this, you can see that the summaries are coming in. This story discusses a notification about unusual activity and so on. All right. So we are coming a little bit closer to the end. I have just a couple more things that I want to show you. And so here's what you remember this architecture diagram. So what we just did is I just demoed sampling. Architecture's pretty much the same as what we saw with elicitation, but now what I'm doing is I'm invoking, and I have a handler on the client side that's invoking that LLM. So it's a different part of the MCP protocol. It uses that context object that I pointed out earlier, and that context object is exactly what's used for logging. So you can also do MCP server-side logging and have it show up in the logs of the AI application on the MCP client side as well. You'll notice that I didn't put a connection over into the temporal workflow, and that you could have done something along those lines, but temporal has great observability, as we just saw. So I'm not bringing the logs all the way from the temporal workflow back into the client. I'm allowing the temporal workflow to manage its own logs. Okay, we just did that demo. And so now we're on to the third topic, which is, well, what happens when these tools are used in headless AI applications, say ambient agents? So with that, let me show you, let me come back over to the temporal UI. And you'll notice that when I was in the middle of showing you um, the details of what happened when we invoked the workflow for the first time, I said, oh, good, look, it kicked in again. And let me show you what happened there. And I'll come back to the code in just a moment. So my demo code, after it runs the Hacker News tool for the first time, my application creates a second workflow. This workflow is not an MCP server implementation. This workflow is an AI agent implementation. So, and this particular AI agent is an ambient agent. There is no chat interface. There is no UI of any kind. It is just doing something on my behalf behind the scenes. And so my application said, you know what? If you've asked for it the first time, I'm going to be super helpful and I'm going to run this for you every day. Now I have it set up for 5 minutes because we're not all together for an entire day. But if I click down into this workflow, you can see exactly what's happening here. So when it kicked in that workflow, it ran call the MCP tool. So that was exactly what happened in the other workflow where I was showing you that and it said, oh, look, it kicked in. It kicked in right here. It called that MCP tool. And then it also did a couple of other things. It converted the output from JSON into Markdown. And then I leveraged an activity that came from another demo that my colleague Steve Androlakis put together with some OpenAI work that we did a few weeks ago and a big announcement that we had. If you haven't seen that, look for it. It's pretty cool. And I used his activity where he used a PDF generator to generate a PDF. And then I slept for 5 minutes. And so here I would likely sleep for a day. I'm not going to run this every 5 minutes. But then you can see that it kicked in and it did all of that over again. So you can see daily I'm getting these reports. Well, what do those reports look like? Well, let me come over here. I am simply dropping them into this PDF output directory. So you can see that I ran a number of these. I've been testing my demo. So far, the demo gods are with me. And so if I click on that, you can see here is the not very elegant, but it is a PDF rendering. So here are the top 5 news stories. And without having to click down into these URLs, I have a brief summary of each one of these. I don't know about you. Maybe there's tools out there that you all use, but I've already found value in this because as I was doing all of this testing, I was reading these summaries and going, ooh, I want to read that article. Something I probably never even would have looked at because I don't spend a lot of time on Hacker News. So this is a real productivity boost for me. Okay, so let's go back to slides. Um, and I have one more topic. And so here is the code for that workflow. Again, all of this is checked into the GitHub repository that I'll show you a QR code for in just a moment. So going back to this architecture, I want to show you just a little bit more. Here are those different workflows. And what I wanted to show you, I really wanted to emphasize here is that we are using temporal workflows for stateful, durable MCP servers. Remember, I didn't need to ask for the AI topic the second time because these are stateful. And even when I stopped my workflow engine, and even when I stopped my client and I brought all those things back, that AI topic was durable inside of my workflow here. So I use temporal workflows for MCP server implementations, but I also use workflows for durable AI agents. Today's topic is more on the right-hand side of this slide, but I also wanted to make sure that y'all understood that temporal works really well on the AI agent side as well. Okay, we already went through that demo. So with that, I know we said 45 minutes. We're going to go just a little bit longer, and this is all going to be recorded. So I apologize for those of you if you do have to drop at the 45-minute mark. This is all going to be on the recording. I invite you to come back and see these few minutes about remote and local MCP. And then we'll have time for a little bit of Q&A at the end. So this is an architectural picture that I actually had put together last month when we talked about the initial Durable MCP webinar. And we didn't have time for it. So today we definitely have time to talk a little bit about this. So in that particular case, I didn't have my own client-side application. I didn't have my own MCP client. So the code that I showed you earlier, that implementation, I didn't have that. I was using Claude Desktop as my application, which embedded in it had an MCP client implementation. So that protocol where you can register the different MCP servers, and then that protocol where it says, get me the list of tools, now make those tools available to the LLM, that was all implemented by Claude Desktop. And it's super, super valuable for you to play with these kinds of tools so that you can see. And you'll notice that in that poll question that we posed, it was quite a long list of different clients, and there's way more than that. So there's a bit of a kind of like MCP client browser war thing starting to happen. It's something that I've noticed in the industry. Super, super interesting. Good for you to experiment with these types of MCP clients. Sure, you can build your own, but experiment with these as well. It really kind of deepens your understanding. Then what we had is we had an MCP server, and this architecture looks pretty much the same with the Hacker News as well. So we're not in Claude Desktop, but you can imagine here that this is AI application, and we've got not a loop in this particular case, we've just got a sequence, but the client is invoking in the server, and that server so far have been running standard IO, is running on the same machine and in the same process, and then making these downstream network requests. And so, but the interesting thing is that without temporal, you don't have durability. So if the network goes out here, you don't have implicit retries. If the client goes down, all of that context, in-memory context, goes poof. You start all over again. If the MCP server goes down for some reason, it's running on the same machine, but it's running in a separate process. If that goes down, poof, you start all over again. So even with the local protocol, as soon as you implement temporal with your workflow, with your business logic happening in the workflow, and your network calls and downstream requests happening through activities, you get durability here. You get durability and state management on the workflow side. And you might notice that you already get, even though you're using a local protocol and plenty of these clients run locally on machines, with local protocols, you're already getting kind of a semi-remote environment. All of this stuff that's outside of the dotted box on the left-hand side, the temporal service, the workflow, the activities, the downstream requests, all of that is happening potentially remote. So even when I'm using the local MCP transport protocol, I've already got some level of remoteness. And that's what this says here. Notice that my MCP server is actually kind of remote. And so this is the picture of what I've been running so far. And now going back to the two different protocols that are supported, and it's only two, there was another one, which was SSE. SSE has been deprecated from the MCP protocol. And that's because they've kind of embedded that into the transport protocol that they do, the remote transport protocol that they do implement right now, which is streamable HTTP. So you can see that SSE is used within that. So we've been doing STDIO, and there's the remote protocol. I do want to show you the difference in the complexity of the transport protocol. So when you're doing remote, the transport protocol is really simple. When you're doing a remote, it's quite complex because you've got this SSE thing going on. And the reason for that is because of this switch between the client, the server now becoming the client, and the client becoming the server. That is all of the complexity that you see on the right-hand side here. And so what we do if we're doing a remote MCP for this same example is that we're now making all of these things remote. The application's going to be running in one process, for example, that protocol handler's running in another process, and then the workflow is running in another process, actually in multiple processes if you're running multiple workers. Okay. Now, if I had more time, I would be demoing this for you, and I'm not going to take the time for that because I want to make sure that we have time for questions. But the thing that I will tell you is that after I had this entire demo working for you, I'd been working entirely with the local protocol. And I thought, well, let me take a shot at this. Let me see what happens if I just use the fast MCP libraries that I'm using inside of my client. So the fast MCP here and the fast MCP here. And what if I just tell it, I'm going to implement a different protocol. I'm going to go to the remote protocol. I literally changed like 4 lines of code from running the server locally to providing a URL to the remote MCP server, so to that MCP protocol handler. And I ran it and it just worked. Now, that's not my brilliance. That's the brilliance of the FastMCP implementation of the remote protocol. So all of that complexity that you saw here, this back and forth, that's all implemented in the FastMCP library. And it just did a brilliant job. So that code is in the GitHub repository as well. You'll find it in a separate branch. And so you can go ahead and there will be, the README is not in there yet, but by the end of the day, there'll be a really nice README that tells you which branch you need to check out and how you can run it in the different terminals that you're going to run in there. Okay, so here's the key takeaways very quickly. MCP server tools are going to orchestrate APIs. That was the great question, Megan, that you brought in from Sophia, is they're going to orchestrate these many downstream APIs. Temporal delivers durability for those MCP protocols, so that's really great. You're going to front the workflow implementations of the MCP tool business logic with this kind of protocol, this MCP protocol handler. You're going to use updates and queries, workflow updates and queries to communicate between that MCP protocol handler and the temporal workflow so that you can implement elicitations and sampling. And it works equally well for local and remote. So these are the key takeaways, and these are kind of the architectural best practices that we want you to use when you're implementing this. So with that, I'm going to bring up, there's two different resources here. And on the left-hand side, you can see the bit.ly and the QR code that'll take you to the GitHub repository that has all of these samples from last month's webinar and this month's webinar. And then there's also a QR code here that takes you to the recording of last month's. So if you didn't get a chance to see that, please do go back and take a look at that. It'll give you some kind of foundational stuff that'll make what we did today even more understandable. So with that, I'll come back to those QR codes in just a moment. I'll hand it back over to you, Megan.
Yeah, thank you so much, Cornelia. That was awesome. You are really the queen of demos. I just it's great. But anyway, so there was one question that I thought we could answer live. I mean, Kevin's been doing an awesome job just getting everything in
Thank you, Kevin.
the Q&A and chat. So thank you so much, Kevin. But Ilya had a question about what's the advantage of keeping state in the workflow rather than a database? And then if I'm not mistaken, keeping state in Temporal will produce a huge event history that will cause performance issues for long running workflows.
Okay. So this is a super complex, nuanced question. So the first thing is, let me answer the first part, which is why would I store it in Temporal and not a database? You could do it in a database, but now you've got a database to manage. You've got database schemas to manage. You've got database security updates to manage. So you're using Temporal to do the orchestration, but you're doing state management somewhere else. So your bill of materials is larger and your operational load is larger. So why not let just Temporal do that state management for you? And that was the second part of your question, which is you suggested a number of reasons why you wouldn't want Temporal to manage that. There's two elements there that I want to talk about. And we are absolutely going to do a webinar on this in the future. And so do please give us feedback if this is something that is super interesting to you. The first thing is long-running workflows. Yes, you're right. The longer the workflow runs, and by now I've run my LLM loop 5 times, right? The longer that workflow runs, the longer the event history goes, the more you're storing on disk, and you might actually run out of space in the event history. The event history can be very large, but you might run out of space. And so one of the things that Temporal does is it has like an abstraction. It has a programming metaphor or paradigm of continue as new. And so what you can do on a periodic basis is say, you know what? Rather than storing this entire long workflow history, I'm going to come to a point where I'm going to say, you know what? That old workflow history, I don't need the details anymore. I'm going to summarize what happened in that context. And then I'm going to continue my workflow. So it's the same workflow, but I'm continuing it and I'm letting go of the old history. Okay, so that's an important thing. Now, and this is where I promise we'll do a webinar in the future. Don't have a date yet. But what I'm talking about here in this like figuring out, remember that the history that I'm storing here is to a large extent the history of my AI application and the interactions between the LLM and these tools, right? And so what we're talking about here is context engineering. So temporal gives you this great abstraction of continue as new. And what you do is you implement your strategy for context engineering. And we just give you a place where you can say, all right, now as I've decided that my context, so this question that you posed of long running and aren't we going to run out of space or aren't we going to have problems? Well, we all know that LLMs, the longer that history goes, they start getting pollution in the context. And that's where the whole context engineering thing is coming in, is that we want to kind of prune and curate the context that's going into the LLMs to optimize the LLM output. So that's what's happening here. So that's one element. The other thing that I'll tell you is that I can tell you that we at Temporal are working on in our product strategies that are going to help you deal with larger payloads. I won't go into the details, but we recognize, especially in these AI use cases, that payloads have gotten larger than they were back in the microservices days. And so we are working on enhancing the support for large payloads in the Temporal product. And so that will help as well. And I'll leave it at that and invite you to stay tuned because we're going to be showing you more stuff as we go along.
All right,
What
thank you so
else?
much. We have one more question from Ellen. So she has a general temporal question. So she says she's working on a project which will have 20 plus service calls from different services, and she wants to know, should she build each of these service calls as an activity, or should she have a few activities and each activity brings the workflow to a particular milestone or state?
So it's a little bit of a nuanced answer. So I'm not, but I promise I'm not going to say it just depends. Your default, you should start with every downstream call gets its own activity. You should start with that because each one of those downstream calls could fail for a number of different reasons. It could fail because of network outages, and if they're each in their own activity, you're going to get very granular retry logic. Also, if each one of those downstream requests does a fair bit of work or incurs costs, let's say a downstream request to an LLM, you're burning tokens. If some failure happens to your overall workflow and you have to recover it in some way, we've recorded every single activity, execution, and the results from it. And so you won't be re-executing those activities. I mean, the activity will look, but it will say you won't re-implement those downstream requests. And so your knee-jerk reaction, your knee-jerk kind of feeling should be, yep, each one of the calls goes into its own activity. I'm sure there's nuances sometimes where you may want to do more than one, but in general, start with each one is its own activity.
All right. Thank you so much, Cornelia. And this is also a good plug for the community Slack, which we mentioned in the chat. So it's a very active community Slack. There's a lot of folks in there answering questions. So if you didn't get your question answered today, just pop over there, and it'll be answered. So again, thank you so much, everyone. Cornelia, that was awesome. We'll be sending out an email with all the links to everything. So keep an eye out for that. And thank you, everyone, for the great engagement. It was a lot of fun today.
Super.
All right.
Thanks
Thank
all.
you.
Bye.